I often get asked about APNs when it comes to 3G and 4G cellular data. And what I want to do in the next couple of slides is just talk through the difference between a public and a private APN, and give you my thoughts on which is I think is the best, and then also how APNs affect SD-WAN and vice versa. So this diagram shows how a public APN works, right? And a public APN is, generally speaking, what we'll all have on our smart devices. And if you go and buy a SIM over the counter from a mobile network provider and pop it into your smartphone or your router or whatever, right? You put in the APN, you put in the SIM, the router connects to the operator network. It logs into the operator network with the public APN, at which point the operator network, generally speaking, will dish out a private IP address, use carrier grade NAT to route you and your traffic through to the internet, and it provides a level of protection as well, right? Because it's NAT, users on the public internet can't route traffic into your device, right? You're behind a NAT router, and generally speaking, this works very well, right? And you normally know if you're on a carrier grade NAT connection because you're in this range, that 100.64 range. Sometimes not, but normally you are. So this is what a private APN looks like. Slightly different. So same scenario. SIM card goes in your router or your smartphone, but instead of using the public APN settings, you put in private APN. And as soon as you do that, what you're actually doing is you're allowing the mobile network operator to identify the source of the traffic and do something different with it, right? So it's a bit like VLANing traffic. It's a bit like, I guess, picture in a normal home domestic enterprise world, picture a wireless access point that you put multiple SSIDs on, all with their own name and password to connect to. It's a very similar idea in that by having a private APN, you've effectively got a private SSID that your router is connecting to, and because your devices are connecting to that private SSID or that private APN, you can subsequently identify that traffic and do useful things with it, right? So in the mobile network operator world, those useful things are custom IP addressing. So if I had 1,000 devices and they all were on my own private APN, I could give an IP range to all of those devices, perhaps even statically assign them if I wanted to on a private IP range, and then all of my devices could all contact each other. Or I might actually want a public IP address, so I'd go on to a specific APN or a private APN and be assigned public IP addressing by the mobile network operator. Or the MNO might offer me different authentication services here, so radius authentication against an enterprise network, and like enterprise radius source or Active Directory or something like that. But the key thing is a private APN lets the mobile network operator know whose device is and whose traffic is being received over that APN. So ultimately, when we talk about private APN in 3G and 4G terms, and when we're talking to customers and they say, I've been told they need a private APN, what those customers are generally speaking looking for is this. They are looking for a private APN that enables their traffic to be isolated from the point where it leaves the remote router on the left here until it gets to the mobile network operator, and then it goes via their VPN gateway over IPsec back to the customer's VPN gateway. So it's a way of extending the corporate LAN over a cellular connection. Now, important and perhaps pedantically here, we've got full encryption using IPsec VPN between the VPN gateways, but we haven't necessarily got massive amounts of encryption or guaranteed encryption over a private APN. That very much depends on the operator. But certainly traffic is isolated when you're on your own APN, right? So you can, as a corporate, give out SIMs for your staff's smartphones, tablets, devices, put them all on a private APN, and then route all of their traffic, internet traffic, back via your corporate network, so you can filter it on your firewall at your corporate network if you want, for compliance purposes. Or you might just want those remote devices and users to have access to internal resources without needing to log in with a VPN client on the device. It's really useful at times. So what happens when you've got multiple mobile network operators? In what I do a lot with Patlink devices is I combine cellular connectivity from multiple operators, right? And if you need to use private APNs in those kind of scenarios, what you additionally need is a mobile virtual network operator in the middle, pretty much. At least that's that's the easiest approach to this, where an MVNO has a VPN gateway. They have their links, IPsec links, or IPsec tunnels, or sometimes dedicated private fiber links between their VPN gateway and the gateways of the different mobile network operators. And then the MVNO manages the relationship with the mobile network operators, and they deal with the data tariffs, and they deal with getting hold of SIMs, and they can then offer a service where no matter which operator you're on, you might get the same IP address allocated to the remote device, and you've got the encryption then between the MVNO and the customer location. I mean, this is quite a tidy approach. It's a bit old-fashioned, but you'll see a lot of mobile virtual network operators offering something like this, and they'll be using OpenVPN, they'll be using IPsec, they'll be offering enhanced billing capability, offering enhanced data packages, and potentially the aggregation of data across multiple operators, which can be really, really handy. Of course, all of that comes at a cost, but it's a good way to start, potentially. So we need to talk about SD-WAN and the alternative approach here to using private APNs, right? In what we're seeing in this diagram here, and the key thing that I want to bring up is when you use an SD-WAN, you're not just aggregating or failing over between multiple cellular links securely. You can add any type of connectivity in the mix. So in this diagram, I'm showing two network operators at the top in the orange, and then in the yellow box below, but highlighted in blue, we've got a fixed line wired connection, a DSL or a fiber, a cable ISP provided circuit, right? Now, the benefit here to SD-WAN is that I can use a public APN on the cellular links quite happily, and my cellular router will create an SD-WAN connection out over all of the available links to my SD-WAN gateway. And in this diagram, I'm hosting the SD-WAN gateway on a public cloud, and I'm doing an IPsec from the public cloud into the customer location. And this diagram is really about showing how you would pull out a private APN infrastructure and throw in an SD-WAN infrastructure and achieve the same end goals with more capability. This ability to use any mobile network operator you like, any type of SIM service really, and then mix in Wi-Fi as WAN and fixed line connectivity as well into the mix. So you've got full resilience, full availability across all of those links. And importantly, you don't need anybody else's help, right? You can do this very easily yourself. The tools are very straightforward, and you can have the direct relationships with the mobile network operators without needing the MVNOs necessarily. Although MVNOs still have their place, these guys work very hard to get the best kind of data contracts and deals, and if you make friends with the right MVNO, they'll solve a lot of issues for you with data and SIMs and SIM management. So they still have value, but what this does, it gives you back control. It makes the internet links commodity links again. And finally, I just want to highlight actually the one of the key differences for SD-WAN, at least for me, and how I think about this stuff, is that okay, in the previous diagram we had an SD-WAN connection between the router and the public cloud, but actually we can do an SD-WAN connection direct to another appliance running in our corporate data center. So we can do full encryption, 256-bit AES encryption from the remote router all the way back to our data center, and without worrying about what the underlying connectivity is or who's encrypting it with what or any of that, right? And that for me is massively important. Now, when we're working with customers as a managed service provider, we'll offer to do this, either way, right? We can either host a public cloud appliance for them, and we'll do this for customers that don't have huge amounts of bandwidth available at their data center location or their headquarters location. Or we can bring an appliance into the customer's data center, into their server room at their location, or we can do a combination of the two. And that's where the real magic of this comes for SD-WAN, in that we can extend an SD-WAN anywhere we like, right? Across the world, across continents, using any operator's network, using any type of technology for internet access, because SD-WAN doesn't care what the underlying connectivity is. And that's the improvement, I think, or at least one of them, over a private APN service. So I hope that helps. It helps clear up, the differences. Any questions, do get in touch. My Twitter handle's Martin Langmaid. I look forward to getting the questions. Thank you.